we have Bytewax. Bytewax maintains an open source data streaming system built entirely in Python. You can use Bytewax to build streaming data pipelines, real-time apps with everything that you need, including recoverability, scalability, windowing, aggregations, and connectors. So today we are going to be hearing from Zander Matheson, the CEO of Bytewax. Zander, I will let you take the stage.
Excited to be here. Thanks for having me. Cool. Let's get started. We don't have a ton of time and there's a bunch to talk about. So thank you for the introduction. I won't repeat what was just said, but a little bit more background on who I am. So currently the founder and CEO of Bytewax. I've been working on Bytewax for about 3 years. The company's built around the open source project, which you can find on GitHub, Bytewax/Bytewax. Prior to that, I worked in data science and machine learning. That was last at GitHub, pre and post the Microsoft acquisition. And then before that, I was at Heroku as it was a part of Salesforce. And not listed on there, but before that, I worked at a speech technology company working on all sorts of things, but they did speech recognition, speaker verification, text-to-speech, and NLP stuff. Before there were chatbots, we were building chatbots there. Or before there were like very sophisticated generative AI chatbots, we were building chatbots there. But today we're going to talk about something else. We're going to talk about how stream processing fits into RAG. So we'll do a quick intro to RAG. We'll go into a real life example of a real-time RAG architecture and talk about the components there. And then we'll dive into the ingestion pipeline, which is where you might encounter stream processing in your work. And then I'll leave you with a working example. It's actually a full workshop that we ran a couple of weeks ago, we being Bytewax, and the code that goes with that. So we all know what RAG is probably here. It's a waste piece of cloth. You know, you might use it to wipe down your furniture. No, I'm just kidding. RAG stands for Retrieval Augmented Generation. So I like to try to minimize the amount of terms you might not have heard before. But RAG, in my mind, is really just taking as much information and context as you possibly can and shoving it into the prompt and specifying that the generative model should return an answer that uses the information that you've shoved in that prompt. So the retrieval part is pulling that information together, whether it's using some simple retrieval from a database or something more advanced. And then the generation and augmented is that shoving in the prompt part. So today, RAG is probably the most efficient way to reduce hallucinations and provide accurate and up-to-date information in AI applications. The key being they're up to date. So how do we keep information up to date? Because as you all know, nobody likes stale data, just like you don't like stale bread. This is absolutely disgusting. The stale bread, that is the image of it. Your customers don't appreciate when you return answers that are out of date using stale data. And so it's increasingly necessary if you're building a generative AI application to provide the most up-to-date information. In most applications, not always, but in most applications, because the world around us is always changing and the data that we generate, which is in the terabytes per day, is always changing and there's always new information that we need to provide. So where does stream processing fit into all this? And like, how do you manage to keep that information up to date? It might seem a little overwhelming, and this architecture diagram that I'll share next might not even help that. But I think it's helpful to walk through a working example with the architecture diagram and all the pieces that are included. So let me walk you through this diagram a little bit. The workshop, this is from the workshop that we did a couple weeks ago, and I'll share the full video. It's 2 hours long. We did it with Microsoft and Unstructured as partners in that workshop. So what this is doing is this is a financial portfolio advisor. So down in the right corner here, a user would specify some stock tickers that they're watching. And this would generate a pipeline that's streaming data from Kafka. And then based on some signals, it will automatically generate a new report about the stock tickers. The data that's used, the data that's used for the financial portfolio advisor is collected in real time from a bunch of resources that are publicly available. So you have some public and some privately available. So you have news articles, you have filings that are PDFs that are on the SEC, Edgar API. If you're not familiar with finance, it's like a whole rabbit hole in itself. Then you have stock market information. And so that's all being streamed into Kafka via Bytewax. And then over here, we're going to take that information and we're going to process it and structure it in such a way that we can put it into a data store, which we'll talk about in a second, and that will be used in that prompt. So this is the whole architecture of the RAG system. You have an ingestion pipeline on the top, and then you have an application on the bottom, and then your data that you've ingested into this data store, you will be injecting into that prompt. So why is Kafka here? What is Kafka? For those of you who aren't familiar with the whole streaming ecosystem, Kafka is a streaming platform that has many parts to it, but it's most well known for the actual transport/storage layer. So Kafka has an API that allows you to interact with a broker. So you send information, that broker will then store that in a log format. And so the data is stored in order, and it's stored to disk. So it's durable and it's replayable, which are both really important concepts because we don't want to lose any data, because if in some instances your data sources here might be almost ephemeral, like you can't replay them from there. So you want to make sure you put them into a durable layer here, just as you would with a regular database. The difference is here, it's replayable in that stream. So things come in, you care about the order, and you want to be able to replay them in an order, or maybe if you have some failures on the other side of Kafka here, and you want to go back in time essentially to where you have an accurate representation of what's going on in whatever these downstream pipelines are, so you can replay from that. Or maybe you're just backfilling, and that's another reason you'll want to be able to replay that. The final thing is it's multi-consumer. So Kafka can have many producers and many consumers, and that gives you the ability to kind of produce that data into Kafka once, and then have many consumers who are using that same data, which in this architecture we would be, because we're using information from Kafka here from the same topics in this pipeline, where we would be like creating some logic to alert and to generate that report from. And then up here, we'll be using that same data to index it and put it into the data store. So the next key component to a real-time RAG architecture is, I should be keeping track of my time here, but I'm not, is the data store. So you've probably heard a ton about vector databases, or at least about the way to search with a vector index. So many databases have the ability to use a vector index and store embeddings, which are the vectors. In this workshop, we used Azure AI Search, but you can really use whatever fits your needs. There's so many options out there, and there are a lot of great options. These bubbles kind of moved, but the final piece that I'll talk about here are just the pipelines themselves. And those are powered by Bytewax. We did also use Haystack and Unstructured. Bytewax is sort of the framework and the processing engine. We'll talk about that in a second. But that's what we use to describe how we're going to connect to, process and transform data, and then ultimately write it out somewhere else. So what is Bytewax? Bytewax is a Python native open source stream processor. And you can broadly think of it as this sort of middleware layer where you embed logic, transformational logic or operational logic using a series of operators into this DAG that you describe how you're changing data, and you're moving it from, most often, you're moving it from one place to another. So you may be doing some pre-aggregation of that data. You may be doing some joining of multiple different sources of data, branching, filtering, enrichment, etc. Bytewax is, well, I'll talk about it more in a second, but the rest of this diagram just basically saying here in the bottom that Bytewax can run almost anywhere. It's cloud native, which gives it an easy deployment story. So why would you use Bytewax for this particular use case? Bytewax is very generally applicable. So why would you use it for RAG specifically? And also I'm going to talk about why did we build Bytewax. So we made Bytewax because the current tools, if you're not familiar with Apache Flink, Spark, Beam, or Storm, Spark is can be used in both streaming and batch use cases. Well, actually most of them can, but essentially these processing engines are just way too hard to use. Generally, like in our personal experience from people on the team and myself or others, it requires a number of engineers. Even to get going, it can take a long time. It lacks the right interface for AI, so it's very difficult to use Python with these tools. They're quite resource intensive, and they're exceptionally expensive to maintain. So all of this culminates in weeks to months to realize ROI on the project. So that's the reason we built Bytewax, is to move that. I hope you like my hand-drawn little chart here, but to move this into the days from weeks to months. And then also to enable people to use the Python ecosystem of tools, which therefore will enable you to use AI and machine learning tooling. So what are the features that make Bytewax possible? So we have first the Python native API. It's built on a Rust engine. It's actually built on top of an open source project called Timely Dataflow. It gives you stateful streaming capabilities. So that's what you need in order to do joins, windows, aggregations, or have stateful connectors that have an idea of where you are, like track your progress. It's easy to deploy and comes with observability, basic observability. It's easily scalable and cloud native. Cloud native kind of lends to that easily scalable story. So it can run on Kubernetes, running Kubernetes. It can use object storage for backing up state, etc. And it comes with recovery included. So it's production ready. Okay, so we'll quickly, with the time remaining, look at like what is a Bytewax workload. We call those data flows, and we'll look at the anatomy of a data flow, and we'll just look at these two of the pipelines that are part of this ingestion in this overall workshop. Okay, so what you're looking at is two pipelines. One connects to SEC, or you're looking at two diagrams of the pipelines. One's connecting to SEC Edgar API to receive the most recent SEC filings, and the other is a custom WebSocket news connector. It's connecting to a financial news feed from Alpaca, which is actually a wrapper around the Benzinga news. So down below, it's like the most recent financial news, and up above, we have the most recent filings pertaining to different publicly traded companies. So a data flow is a series of steps. Data flow, which is one word, we use it to describe these workloads, but a data flow itself is a programming paradigm where each compute is its own step in a directed graph. So in this case, after we pull the SEC website, we'll get a Atom feed that we can parse, and then from that we'll get a list of filings, and we can deduplicate those filings in a stateful step, because we'll have, if we're polling, we'll have most likely, depending on the interval, you'll have duplicates. We can then enrich this data with some more stock or some more company information, serialize it, and then write it to Kafka. So we're describing in the data flow, we're describing the different steps that we're going to take to move data from this raw Atom feed to something that we can then use downstream, which is going to be the filing information itself. So I'll just quickly show you what that code would look like. Sorry, I have the wrong link here. Maybe I put it here. Sorry. There we go. So this is the SEC filings website. So basically what I want to show, and we don't have a lot of time left, is just it's too much information to kind of grok all at once, but Bytewax gives you the hooks and semantics to describe how you connect to almost anything. Anything you can, there's a Python client library for, you can connect to. There are like some caveats because of depending on what guarantees you want, etc. But so in this case, we're connecting to the SEC Edgar website, and we're just going to pass out the list, or sorry, that Atom XML data file object. So we create that custom input, and that could be literally anything. Then we set up a data flow object, and we specify our input with that input source and whatever parameters that input source requires. And then each successive step, what I really wanted to show is that there's the ID of operators. So each node in that graph that I have shown is an operator. And in that operator, you will write some Python code to describe how you're changing that data. So we have a flat map here, and there's many different operators, and we write those operators, but you can also write custom operators. So you can have maps, windows, joins, et cetera, and then we provide those with some custom code. In this case, it's the code to parse that Atom file and pull out the individual entries. A flat map means I'm taking one thing and splitting it into many objects downstream. And then what we put that, the variable that we provide here for the output of that flat map, that's going to be our stream handle. You can think of it as almost like a generator object. So it's like you're iterating through that stream, and each successive step, now we have our stateful map where we're doing duping. We're going to pass that stream handle, which you can think of it as like, okay, we're passing that generator object. And then Bytewax itself is going to iterate through that. And Bytewax will take care of coordinating everything. I think I'm out of time, so I better wrap up. It will take care of coordinating everything and allowing you to scale, et cetera. So that's it. The whole YouTube video is here. I'm going to put it in the chat, I think, and I'll put this in here too and wrap it up. All right. Thanks everyone for listening. And I'll drop off here and stop sharing my screen.
Cool. Hello, Megan. Hello, Zander. Thanks, Zander.
Thanks, Zander.